let's work this problem. A solution is made by dissolving 0.1 moles of sodium chloride in 8.60 moles of water, and what the problem wants is the mass percent. So you'll get lots of problems like this where you'll get different values for the solute and solvent. It won't be straightforward. You'll have to do a couple of conversions before you ultimately get the unit of concentration. That's typical of this type of problem. So the way to remember this is to define the unit. So if you remember mass percent, remember this is per 100, this is going to be the mass in grams of sodium chloride divided by the total mass. And the total mass is the sum of the grams of NaCl plus the grams of H2O. So you've got the total mass, and then you'll just multiply it by 100. That's going to give you your mass percent. So we need to go ahead and convert moles to grams. That's an easy calculation. So X grams of sodium chloride, you've got 0.100 moles of sodium chloride. This is NaCl. And 1 mole of NaCl is equal to 58.45 grams of sodium chloride. So when we multiply across, moles of sodium chloride will cancel, and we'll wind up with, this is pretty easy because this is just 0.1, so that's going to be 5.845 grams of NaCl. We just wind up moving the decimal place one place to the left because we're multiplying by a tenth. So it's going to be a tenth of this. And then we're going to do the same thing for water. This is X grams of H2O. That's our solvent. We've got 8.60 moles of H2O, and every 1 mole of H2O weighs 18.02 grams. And when I multiply that one I can't do in my head. That's going to be 8.6 times 18.02. I wind up with 154.97. 154.97 grams to get the total mass. I'm just going to add these two guys up. So to that, I'm going to add 5.845, and I get 160.8. So that's 160.8 grams, and that's the total mass of the solution. Okay, so total mass of solution. Okay, one more step. This is X mass percent, sodium chloride, NaCl, and that's just going to be my 845 grams of sodium chloride divided by 160.8 grams total mass, and then I multiply times 100. The masses will cancel, and I'll wind up with percent. So 5.845 divided by, and that gives me 3.63% by mass. 3.63% NaCl by mass. So if I'm doing this by mass, I have a total solution. I've got sodium cations and chloride anions in here. I take the total mass of that solution. The mass of that sodium chloride in there is going to be 3.63%. Okay. Parts by volume, defined as the volume of solute divided by the volume of the solution. You'll see this every now and then. I don't encounter it too much, but it's just volume percent. It'll be the volume of the solute divided by the volume of the solution times 100. Just make sure these two units are the same. It's either liters over liters, milliliters over milliliters, etc. Okay, so I don't think need to do an example of that. Often abbreviated as percent V over V. Converting from one unit to another sometimes can be problematic, but it's not too bad if you remember what the definitions of the different units are, and remember that you need to use density to convert from mass to volume or volume to mass. And this is saying we've got an 8 mass percent solution of ammonia. They give us a density. You'll always be getting a density when you're converting things like mass percent to molality, or molality to molarity, or molarity to molality. You can't do it without a density. And finally, we want to do the mole fraction of ammonia, and they gave you the formula of ammonia so you can compute the molar mass. Okay, this is quite the problem. So first of all, what is mass percent? Well, remember, percent is per 100. So whenever you're giving a percent and you don't have a total mass already, you just go ahead and you assume a total mass of 100 grams. And if you assume a total mass of 100 grams and percent becomes a piece of cake, if this is ammonia, then 8.00 grams of NH3 divided by 100 grams of solution times 100, well, that's what would give you, okay, times 100, that's what would give you your 8 mass percent ammonia. So if you're not given a total mass, but you're given a percent by mass, just assume a total mass of 100 grams of solution. All right, let's start. We've got 8.00 grams of NH3 over 100 grams of solution. Let's start out with this. Molality. What is the unit molality? Well, molality is this. Molality is moles of solute, our solute is ammonia, over kilograms of solvent, and our solvent is H2O. We need molarity. Molarity is equal to moles of our solute, which is NH3. This and this, those are going to be the same numbers initially. And then we have to have liters of solution. Finally, we have mole fraction, and mole fraction actually has a symbol that is a little unusual. It's a big italic X, kind of looks like that, and that's just going to be moles of our solute NH3 over total moles of solution. Okay, we need in all three cases moles of ammonia. So why don't we start there, and then we can figure out how to get to kilograms of solvent, liters of solution, and total moles of solution. All right, so first of all, X moles of NH3. Well, I know how many grams of NH3 I have since it's 8 mass percent. I've assumed 100 grams of solution. 8 grams of that solution are ammonia, NH3. So I'm just going to divide by the molar mass of ammonia. Nitrogen is 14.01 plus 3.03, and that gives us 17.04 grams per mole. That gives me 0.469 to 3 sig figs. 0.469 moles of NH3. I'm going to use that throughout all of these conversions. All right, let's go for molality first. What we want is kilograms of our solvent, which is H2O. That's going to help skip molality. And the way we do that is, well, we got 100 grams of solution. And if I subtract the 8 grams of my NH3, which is my solute, that's going to leave me with 92 grams of H2O. And I'm going to go ahead and divide that by 1,000 grams per kilogram. Grams will cancel. I'll be moving the decimal place 3 places to the left. That gives me 0.0920 kilograms. All right, I can go ahead and get molality now by dividing my 0.469 moles of ammonia by my 0.920 kilograms, but I'd like to go ahead and find out how many liters of solution I have and what the mole fraction is. So I think the easiest way to do that is to go ahead and get moles of my solvent water. This is H2O. So I've got 92 grams of water. The molar mass of water is 18.02 grams per mole. Grams will cancel. So that's 92 divided by 18.02. That gives me 5.11 moles. So I have 5.11 moles of H2O, and I'm labeling everything so I don't lose any of these values when I try and do my ultimate calculations. All right, one more. We need liters of solution for the molarity. Well, wait a minute. Let's go ahead and get total moles for the mole fraction. So total moles. And the total moles will just be the moles of ammonia. That's the 0.469, so 0.469 moles. And that's my NH3 plus my 5.11 moles. That's my solvent H2O. So that's going to just be 0.469 plus, and I've already got that answer in there, that gives me 5.57 moles total. So 5.57 moles total. Okay, one more. I need X liters of solution. Well, that one's easy. That's where I'm going to use my density. I know I have 100 grams of solution. That's my assumption. And my density is 0.9651 grams per mil, so 0.9651 grams for every 1 milliliter of solution. I'll go ahead and convert milliliters to liters by dividing by 1,000, and there I go. So that's going to be 100 divided by 0.9651 divided by 1,000, and that gives me 0.1036. So 0.1036 liters. 36 liters. This is my solution volume in liters. Okay, let's go ahead and let's do molality first. So that's going to be X moles per kilogram, and that will be 0.469 moles of ammonia divided by, how many kilograms did we have? 0.0920 kilograms. That'll be my molality, so we'll do that. 5.10 molal. So my molality is 5.10 lower case m, that's my moles per kilogram, moles of solute. And don't forget, this is kilograms of water, which is my solvent. Let's go ahead and do the molarity. This is going to be X moles per liter. We've still got 0.469 moles of ammonia, NH3, 0.1036 liters. You should be more disciplined and neater in the way that you organize your information than I am. So that's 0.469 divided by 0.1036. And that gives me 4.53 molar. So that's 4.53 molar. I want you to notice that the molality and the molarity are pretty close together for this dilute solution, with the molarity being a little bit lower, because if you'll notice, you've got the entire solution in your denominator. You've got the same number of moles in this solution, and then over here with the molality, you're only dividing by kilograms of the solvent. So you have less stuff in the denominator over here, which gives you a larger value for your molality. Okay, just an artifact of those two units of concentration. One more, let's do X moles of NH3, that's our solute. This is the mole fraction, and the total moles, this is total moles down here. That's going to be 0.469 moles of ammonia divided by 5.57 moles. This will always be a number less than 1 because you're dealing with a fraction of the total. This is total moles down here. So that's just going to be 0.469 divided by 5.57, and that's going to give you 0.0842. Okay, 0.084.